Okay, so that's confidence interval. And this one is for testing statistical hypothesis. We have a sample of 8. Okay. And what we should test, the research we should test whether the average vegetable consumption is different from 5 pounds per week. So what kind of test is it? You know that immediately. But anyway, when you see this statement, immediately you can write down your hypothesis, right? What is your null hypothesis? Usually we use the notation H0, right? You're testing whether the average, population average, right? Average consumption is different from 5 pounds, so that the null hypothesis will be same as 5 pounds, so that's a null hypothesis. Your alternative hypothesis that the mean is different from 5 pounds. Sorry? So yes.
When you write it,
You have to, if you want to use these notation, math notation, you have to use mu, right? This a lot of times students use x bar. That's wrong, right? It's not x bar. It's mu, mean of the population. You wish to test the average consumption of the population, right? Is different from 5 or not. If you are not comfortable with using mu, or you say you forgot, right, what notation you use, just write it. Write it down. What's your null hypothesis? The mean of the population, the average consumption of the population, right, is 5, and versus the average consumption population is different from 5. Right? You can write it, right, a phrase or a sentence there. Okay. Okay. And what are the sample mean and sample standard deviation? So that's you have to calculate it using the data, right? Using this data, you calculate the sample mean and you calculate the sample standard deviation. All right, so what are these? 3.76 and 1.56. So that's your sample mean and sample standard deviation. And this is small data, okay? The only test that we have learned for small data for testing mean of a distribution is a t-test, all right? Actually, I said that for testing mean, you will always use a t-test. If you have large sample, we learn a z-test, but t-test is about the same, right? So just stay with t-test. And software, most of the software just give you t-test, right? So you just do the t-test. Now, if one wishes to perform the t-test of this data, is normality assumption necessary? Yes, because you have a small sample. If you do have large sample, then you don't have to worry about it. But if you have small sample, you want to test for normality, right? Okay, and we have software to do that. Okay, or if you can do a quantile plot, right? But anyway. So yes, normality assumption is necessary. Although people say that the t-test is somewhat robust against normality, which means if your data is not normal, t-test still works very well. But if your data is extremely skewed, right, t-test is really not a good idea. Okay. What is the value of a t-statistic? T-statistic and z-statistic, actually they are the same thing. Right? You're standardizing your sample mean. By using sample mean, subtract the mean under null hypothesis, divide by the sample standard deviation over square root of sample size. We have 8 of them, right? So. Yeah. Okay. So it's a sample mean minus the mean under knob. Don't flip this thing, all right? This one has to go first. Your sample mean has to go first. Okay. Subtract the mean under null hypothesis, divide by standard deviation over square root n. So what is this? Do you remember? Anybody has this? Mean 3.76. Standard deviation 1.56. Is it negative 2.25 around? Okay. Negative 2.25. Okay. Now, when you're doing your hypothesis testing, this is your first step, right? Stating your hypothesis. Then this is the second step. Compute your test statistic. Choose a proper procedure and compute your test statistic. Okay. And of course, before you do any of these, since it is a hypothesis testing problem, you should have a level of significance determined, right? To determine, at what level the evidence is statistically significant, right? And we said 5% or 0.05. That's a number you can compare with your p-value to see whether you reject the null hypothesis or not. Okay. So at 5% level of significance, is there significant evidence to support the alternative that hypothesis that the average vegetable consumption is different from 5 pounds? Well, there are two approaches to do this, right? Critical value approach or p-value approach, and I kind of emphasize p-value approach, right? We don't have to do both, right? But you definitely need to know the p-value, right? If you know the p-value, how to interpret the outcome, okay? Let's do a p-value approach, okay? Well, in fact, here they also ask you, is the p-value greater than 0.005? Right? Anyway, what would be the p-value then? This is a t-test with the degrees of freedom. What's the degrees of freedom? Degrees 7, right? Because sample size is 8. Okay. If you take p-value approach, your decision rule always that you reject null hypothesis if the p-value is less than alpha. All right. In this case, it's 0.05. All right. You reject the null hypothesis if the p-value is less than 0.05. Now, what's the p-value? From this alternative, you know that this is a two-sided test. So the p-value will be twice the tail area once you found the test statistic. Okay? What's a test statistic? Negative 2.25. This is a t-curve. Negative 2.25 is somewhere here. Okay? This is a t-curve. The p-value for two-sided test is twice this tail area. Okay. Now, if we look at it, it's the same as if you have a number that's 2.25, twice this area, the same thing. Okay. But our table is actually marvelous, right? If you have the test statistic, they can figure out the two-sided p-value. So let's look at our t-table. Our statistic is 2.25. 2.25. Let me zoom in. 2.25, well, actually, degrees of freedom was 7. And so that's the distribution is on this row. 2.25 is in between these 2 points. Okay? And it's 2 tail alpha. That means if you have statistics in between these two, it's 2 tail area will be in between these two numbers. Or we say the p-value is in between these two numbers. Right? Because your 2.25 is in between these two numbers, t-squared. So there are 2 tail areas between 0.1 and 0.05. That means the p-value in this problem, this p-value, right, for this problem is in between 0.05 and 0.1, okay, or 0.10. Remember, we have a t-score 2.25, and it's in between these two numbers. So there are 2 tail areas between 0.01 and 0.1 and 0.05, right? Greater than 0.05 and less than 0.01 at 0.1. Well, will you reject the null hypothesis? Go back to the chart, okay. 2.25 is between 1.895 and 2.365, right? That's for degrees of freedom 7. In this distribution, if you have these two score, or if you have a score like this, its two-sided area is 0.1, which means if this point is 1.895, then two sides of this tail area is 0.1. Okay. If it is 2.365, if this point is 2.365, then 2 times of this tail area is 0.05. But our score is 2.25. It's in between 1.895 and 2.365. So the two tail area is in between these two numbers. Okay. But you notice between these two numbers, that's good enough for us to make decision, because we know that p-value is higher than 0.05, not less than 0.05. So will you reject the null hypothesis? No. Okay? Your p-value is higher than 0.05. Again, this p-value is kind of the likelihood of null hypothesis being true. Right? If this p-value is so small, that means your null hypothesis is not true. You will reject the null hypothesis. How small is small enough? If it's smaller than this level of significance that you specify for the test, in this problem we use 0.05. So if your p-value is less than 0.05, your null hypothesis is not true, or you're not going to you're going to reject the null hypothesis. You're not going to reject the null hypothesis, right? That probably is not small enough for you to reject the null hypothesis. Okay. Now, if you want to take critical value approach in what you do, this is a two-sided test. So you should figure out the two critical values. What would be the two critical values? Well, you got to find those out, right? What would be the critical value if I want to figure out critical value? Critical value will be 2 points such that this total tail area is 0.05. Right? What will be these 2 points? You come to this table. For two tail area 0.05, what will be the t-score? 2.365, right? That means if you have 2.365 here and negative 2.365 here, these should be the cutoff. If your test statistic greater than 2.365 or less than negative 2.365, then your test statistic is in the rejection region. You reject null hypothesis. However, your negative 2.25 is somewhere here, negative 2.25. Not smaller than negative 2.365, not greater than 2.365. It's in the non-rejection region, so we don't reject null hypothesis. The conclusion is the same as this, right? This one, the p-value is higher than 0.05, we don't reject null hypothesis. Here, your statistic is not in the rejection region, you don't reject null hypothesis. No matter which approach you take, the conclusion should be the same. Right? You fail to reject null hypothesis. We don't have sufficient evidence to support that the average vegetable consumption is different from 5 pounds. Okay? Make sense? Okay.